Alright, hi, Mr. Ko here again. Today's topic is to compare and order rational numbers. Our main goal for today is we're going to compare and order rational numbers. So let's start off with drawing out a number line. So make sure that you have a number line. A simple one is good, just so that you have the basics of where things are going. So you have your 1, your 2, your negatives here, -2, and don't forget you can also have your 1/2 here. You can also call that 0.5, and so on and so on. Just have a number line out somewhere or drawn somewhere, so that way you'll have you can use it for reference. Because a lot of what we're doing today is number line based, makes things a little bit easier. All right. So the first thing we're going to do is compare fractions. Now fractions is one of the easier things to compare, just because all we really have to do when we compare fractions is make sure that the denominators are the same. And how do we find, to make sure that the denominators are the same when they're different, is we're going to find a thing called the LCD, or the least common denominator. So if you look at 6 and 10, you can just multiply them together and just get 60. I would prefer to just get one that's a little bit less, so we don't have to do so much of the multiplication, but you can just do 60, it's okay. I'm going to use 30 because 6 times 5 is 30, and then 10 times 3 is 30. So I'm going to go ahead and do that. So here, times 5, that's going to give me 30. If I multiply that by 5, don't forget you have to multiply your top by 5, that gives me 25. Here, I want 30, which means I multiply this by 3, multiply this by 3, which gives me 21. Now we can go ahead and compare, because both of our denominators are the same, we just have to compare the tops. Now if you look at 25, 21, of course your 25 is going to be larger than 21. Okay, let's do the same thing with this one. Here we have 2/3 and 4/5. So let's go ahead and make this a negative and make this a negative, just to make things a little bit more challenging. Okay, so here, first off, let's go ahead and make sure that our denominator is the same. We're going to go ahead and choose the number 15, and that you can just multiply them together, or you could have just figured things out. 3 times 5 is 15, 5 times 3 is 15. So here we want 15, which means multiply this by 5, multiply this by 5, I'm going to get 10. Now don't forget, we're going to continue with the negative, so let's leave the negative right here. On this side, we want 15 as well, because remember we're comparing so that would have the same denominators. 5 times 3, times this by 3, we now have -12. Now, it gets a little bit trickier here because, and that's why you want to go back to your number line. That number line is going to let you know which one of these is the larger number, or the larger value. And according to what we know about the number line, the further right is going to be your larger value. So if you look at -10 and -12, on your number line, and if we were to just draw a very quick number line and just start off with -10, -11 is going this way. So which means -12 is right here. -10 is a lot closer towards the right, so which would make this your larger number. Okay, so use that with this one. Alright, now, what happens if we have something like this? Well, we can do two things. I would prefer to just kind of go with one specific way on how to do this. Let's just change them into improper fractions, makes things a little bit easier. Or you could just worry about the fractions, since our front numbers, whole numbers, are the same. But I'm going to change them to improper. That's 45 plus 2, that's 47 ninths. Right here, 5 times 7, 35, 37 over 7. Now, I would like this and this to be the same number, so looking at it, I think probably about 63 would be good. So I'm actually going to multiply this bottom part right here by 7, times that by 7. Now, again, this does seem like the harder one to do, but if you continue with this and change all your improper mixed numbers into improper fractions, it does get a little bit easier when you're doing other things like adding and subtracting. Okay, so here's 63. This one, I'm multiplying this by 9, which means I'm multiplying this by 9. So 47 times 7, 9, 4, 28, 32. So 329 right here. Oops. On this side, 37 times 9, that's 63, plus 6 here, 27, plus 6. So here is 3, 3, 3. Now, looking at both of these, 329, 333 over 63. That's an easy one, since it's not a negative at all. That side is bigger. Okay? Alright. This was comparing fractions by finding the LCD. Okay, so now what happens when we have a fraction as well as a decimal? So well, first of all, what we need to think about here is we can just logically think about the numbers, but sometimes they're quite close, so you don't want to just look at them and just go, oh, I know this side's bigger or this side's bigger. Let's go ahead and turn them into the same thing. Either you can turn them into both fractions or both decimals. I like using decimals just because it's a lot more precise in this case. Okay, so in order to turn this into a decimal, I'm going to have to go and do some long division. So don't forget, in, out. So I'm going to have 5 on the outside, 2, and I'm going to need a holder here. That way it gives me the answer, because that way it allows me to go and divide 5 into 20 instead of 2. That's going to give me 0.4. And then I'm going to put an extra 0 here, which makes our answer 0.40. And the reason I did this is because I needed to match the same amount of digits here. Okay? Don't forget, 0.4, you can add an extra 0. Now I can look at these two, 0.40, 0.45, and that's an obvious one, which makes the 0.45 or 45 hundredths larger than the 40 hundredths. Okay, let's have a look at this one. This one's a little bit harder. You have 0.3 or 3/10, and you have 1/3. So we're going to go ahead and take 1/3, and that's going to be 1.0. And this was 1/3 was one of the fractions that I told you to kind of memorize, because this one comes out to be repeating 3. Since this is a repeating 3, that's what it would look like. So it would just keep on going on and on and on. This is a 0.3. Now if I were to go ahead and add an extra number right here, the only thing I can add on to that without changing this value is to put a 0 right here. Just by looking at this already, even though that one goes on forever and ever, you look here and you look here, well, 0.30 is going to be less than 0.33. So this is going to be your symbol for that. Now, right here, you have 1/9, and you are comparing that to 0.1. So let's do the same thing here. You have 9, divide that into 1.0, and don't forget they are both negatives, so we can just tack that on later. So that's going to be 1 time, that's going to be -9, 1, bring it 0. You're probably starting to see a pattern here. It's all going to be 1s throughout here. So what you're really doing here is you're comparing this to 0.1, and we're going to go and tack on a 0 right here. So looking at this right now, this is a negative, and this is a negative. You can consider this as a -11, but it really doesn't matter, because even on a number line, your 10 on negatives is still on the right side of the -11, which means this number is actually larger. Alright, so our final and last thing that we need to do here is we need to order rational numbers. And they've given you 4 numbers here that we need to go ahead and put into least to greatest order. So let's start off with 14/4. And since most of these are already in a decimal type of format, we're going to go ahead and just change this into a decimal by dividing. So you have 4 divided by 14. Notice again, that top number goes inside. Okay, 4 into 14 is going to give us 3 times. That's -12, and that's going to give me 2 left. Let's go ahead and add an extra 0 right here, bring that down. That allows us to put 4 into 20, which makes us 3.5. And this is a positive 3.5. And once we get this, it's actually quite easy to look at, and we can just use a number line. So let's go ahead and draw a number line. And let's go ahead and put in our certain numbers. Let's go and do 0, which is our nice one. Now we know that 6, that's an easy number, so let's put 6 all the way right here, because we know that's a positive 6. And we know that 3.5 is going to be somewhere in between, so that's going to be about 3.5, maybe a little bit more further this way, but it's about in the middle, because we're only doing 4 numbers anyway. Now is the hard part. So here, -2.5 and -3.4, well, if you look at how the numbers are going, on this one, if I do -1, -2, And if I continue, negative 3, looking at where negative 2.5 is, well, here's negative 1. In between here would be negative 1.5. Here it's negative 2. In between here, that's your negative 2.5, which would make negative 3.4 negative 3.4. So, looking at how you're going to graph this out, or to do a least to greatest order, just go down left to right. This would be your lowest, so negative 3.4. The next number would be negative 2.5. The next number would be 3.5. And the next number would be 6. Okay? You could put little dots here if you needed to, so that way you have ideas of where your numbers are going to be at. Okay? And that's it. So the main thing about this one is change the decimals. Makes things a lot easier.